friends. It's me, Mrs. S. Today to start or this week we're going to be working on the states of matter. And to do so, I thought it'd be really fun to include a narration. If your library card doesn't work, I am going to go ahead and read the narration that we're going to do together. But if it does work and you would like to read over it yourself, you're more than welcome to. The book that we're reading is It Doesn't Matter, Different States of Matter. So let's start. Matter is everything which occupies space and mass. Three common states of matter are solids, liquids, and gas. And then it goes into differentiating between solids, liquids, and gas. So if you look here, solids, I want you guys to recall particle theory that we discussed last week. We discussed particle theory so that it can help you guys tie into how solids, liquids, and gases work. So the solid, if you look at this, all these little tiny particles are really, really, really close knit together. In liquid, the particles are a little bit further apart, right? So I don't know if you can see the difference here. Really tight together. There's no space for air or anything creating that solid. The liquid, there are little spaces in between here, allowing for you to flow your hands through it and things like this. And last but not least, if you look at gas, look at these particles. They are super spaced away from each other, especially in comparison to the solid and the liquid. All right, let's read on. The properties of these states can be explained in terms of kinetic theory of matter. Matter is made up of small particles. The particles are in constant motion. Solids. Solid properties of states of matter and kinetic theory of matter, shape, volume, particles are arranged in a fixed pattern. Hence, they have definite shape. We know when matter is a solid when they keep their shape unless they are broken. Do not flow on or pour liquids. So you know that something is a solid basically when it keeps its shape unless it's broken. So like a desk or a computer and so forth. Alright, they have an example of a desk, which is a solid, and now it looks like we're going into liquids because I see water. Liquid. Then they have a cow with a glass of milk, so that would be a liquid. Liquid shape volume particles are arranged liquid shape volume particles are arranged in the form of clusters with little intermolecular, it's so hard for me to pronounce that word, spaces between them. They do not have a definite shape since they take the shape of the container. Because of the spaces between the particles, the volume of the liquids is definite. We can tell when a matter is a liquid when they do not keep their own shape. They take up the shape of the container they are in. So if you see here this orange juice, if we poured it in a different container, it would be a different form. Like, I don't know if you guys have been to Burger King and they have like it's in like a milk box carton. And that's totally a different shape from the glass. Gas. Gases' shape, volume, particles are spaced wide apart. They occupy the shape of the container. Since they move randomly and occupy the shape of the container, they have no definite volume. There are other gases besides the gases in the air. Most gases, including the gases in the air, are invisible. You simply cannot see them. So It basically says that gases, the particles are far apart. Most gases, of course, are going to be invisible and they take up a lot of space. So if you think about blowing up a balloon or using helium to blow up a balloon, it fills that space up with the particles. And it's invisible where you can't see it. So if you pop that balloon, you don't see like a cloud full of anything. It's just invisible. And that's pretty much it. So I hope you guys enjoyed the reading. I do have some other activities we're going to do, but this week it's going to be pretty simple. It's just focusing on states of matter. All right, thank you, and I will talk to you soon.